Good afternoon, Professor Somani here. From today onwards, I will take your digital communication subject. So in today's session, we can start our first unit, that is the digital transmission of analog signal. So what is meant by the transmission? Data transmission, or we can say the data reception. It means what? If we are transferring the data, it means data transmission is defined as it is a transfer and the reception of the data over a point to point, or that will be a point to multi-point communication channel. It means what? We can transfer here data. That data may be analog or the digital. So what we can say about the data transmission? Data transmission is nothing but it is the transfer and the reception of a data over a point to point or point to multi-point channel communications. If you see, we can take as example like copper wire, optical fiber, wireless communication channel, computer buses. On that we are transferring the data. So the data represented as electromagnetic signal, such as you can take radio wave, you can take microwave. These are nothing but the data transmission. It means we can transfer the data. And if you see, the data will represented like a electromagnetic signal. Can be, we can take example like electrical voltage, microwave, infrared signal. But here we are supposed to study about the digital transmission of the analog signal. What we are saying about the transmission? If it is transferring the data from one point to multi-point or one point to the one point. Analog transmission is nothing but it is also the transmission method of conveying audio signal. Audio is nothing but analog signal. That signal can be your voice, data, image, video information. It means what? We can convert that signal, analog signal, using a continuous signal which varies in amplitude. It means what? Here the message are represented by sequence of the pulses, or we can say that as a line code, or you can say it is carried out by using the modem equipment. So according to the common definition of digital signal, both baseband and the passband signal, both will represent bit stream data. So we can say his transmission of data according to the most common definition of the digital signal. We can say if data is transferring at that time, we can say that transmission as a data transmission. And here we can transmit that data. That data may be digital message which is originating from the data source. If you take any example, you can take our computer, the keyboard. It also be analog signal such as our phone, video signals digitized into a stream. So there are different types of the transmission like pulse code modulations. We can transfer the data by using the pulse code modulation, or we can transfer data by using the source coding analog to digital transmission, or we can say data compression. We can transfer the data. So here we are supposed to study about the communication. What does mean by communication? Communication is nothing but the transfer of data. It means what? If you guys are talking to each other, how we can do? We can transfer our video or our audio signal. It means what? We can transfer that analog signal. So here communication is to transfer information from source to recipient via any medium, or you can transfer this data using any channel. So if you see the block diagram for the communication system, it will look like this. You can see here when we will give input, at that time we can say this as a source. After that we can use the transmitter to transmit this data. You can use transmitter as transducer, amplifier, oscillator, antenna, anything. After that what we can do? We are supposed to transfer this data to other any single point or the multi-point. So we will require the channel. It means what? If we are transferring the data, we can transfer that data by using the wire, or we can transfer this data by using the optical fiber, any cable. These are nothing but these are the types of the channels. After that what will do? Receiver will receive that data. So we can use antenna, amplifier, oscillator, power amplifier, transducer. These can be used as a receiver. After that, what will happen? When we will get the data at the receiver, it can give directly to the recipient who wanted that signal. So here we can take any example. We can also take that data. So we can say person also, we can say loudspeaker, computer. These are also the type of the recipients. It means what? In the digital transmission, we are supposed to transfer the data. That data we can transfer by using the transmitter, channel and receiver. We can transfer that data by using any channel. You can use cable, you can use optical fiber, free space, you can transfer the data. If you guys are talking with each other, how we can we are transferring the data? We can transfer this data by using the free air. If you are sitting near to each other, you can directly talk and it will go to other person. But like now I am delivering my lecture, I am recording, and after that you guys will hear what I am talking. It means what? You can transfer this data by using cable, you can transfer that data by using wire, or we can transfer data through free space also. So data can be stored in two ways. That can be analog or the digital. If we are using the computer, at that time we will require data that will be in the form of, can anyone tell me? That data will be in the form of digital, because computer only understand the discrete signal. If you are talking about the data, what we can say? Signal can also use in analog and the digital form. It means what? We can transfer analog data or we can transfer the digital data also. So here, to transfer data digitally, firstly we will require that data to convert into a digital form. How we can convert? We can use ADC, which will convert that analog into a digital, or we can again use digital to digital conversion. It means what? If we will require to convert any digital signal into other digital signal, we can convert that data by using the digital to digital conversion. It can be done in two ways. We can make line coding or we can make block coding for transferring the data. How we are transferring the data? By converting digital signal into a digital data. So if you see, we can transfer this data by using the two methods. Which methods? The line coding or the block coding. But if you see, for all communications, line coding is necessary and block coding is optional. So what is meant by line coding? The process for converting the digital data into a digital signal is said to be line coding. Digital data is found in the binary format, and we can represent that data by using the binary number. These are nothing but 0 and 1. So we can take that data in the series of ones and zeros. So here we can say digital data is denoted by the discrete signal, which will represent the digital data. Again, what we are saying? We can use the line coding to transfer the data. How we are transferring? We are converting digital data into a digital. So there are again three types in the line coding, like unipolar, polar and the bipolar. So what is meant by unipolar coding? If we are using the unipolar encoding to transfer the data, we can use single voltage level to represent that data. So if we are representing the data by using the binary, what will happen? Higher voltage will transmit it, because we are taking the maximum value of the binary number. And if you are taking the value 0, what will happen? If we are taking value as 0, there will be no voltage will get transmitted, because we are saying only we are supposed to use one digit, because we are saying unipolar encoding. So we can say if there is no voltage transmitted, we can say it is called as a unipolar non-return to 0, because there is no rest condition, that is between 0 and 1. It is not representing 0 or 1, so we can say this unipolar encoding as a unipolar non-return to 0 encoding. Again, what we are saying, again there is a different type of the line encoding, that is nothing but the polar encoding. So polar encoding scheme uses multiple voltage level to represent the binary value. Unipolar में हम क्या कर रहे थे, we are sending the data but only we are using the one digit, but in polar encoding that will uses the multiple voltage level to represent the binary values. And if you see, polar encoding is available in different types like polar non-return to 0. It means what? It will represent two different voltage level to represent the binary value. You can take +1 as positive voltage and you can take negative value as a 0 volt. So we can say this type of polar encoding as non-return to 0, NRZ. NRZ encoding, that is nothing but non-return to 0 polar encoding. After that, what we are saying? Again we can take polar encoding as return to 0. It means what? RZ. R is for return, Z for 0. RZ. So if you see, there is a problem with non-return to 0 because the receiver cannot conclude when bit ended and when there is a next bit is started. In that case, when sender and receiver clock are not synchronized, at that time we can use return to 0, which will uses the 3 voltage level. Positive voltage which will represent 1, negative voltage which will represent 0, and 0 voltage there will be no voltage. Negative means what? It is representing. 0 represents the 0 volt voltage. Positive will represent 1 volt voltage. And if we are taking the 0 volt, it will represent there will be no voltage. Again we can take Manchester, differential Manchester, which we can say as a polar encoding. After that, we can transfer the data by using the bipolar encoding. Bipolar means what? That type of encoding uses the 3 voltage level. These are nothing but positive, negative and the 0. So, voltage that will represent binary 0 and binary 1 represented alternating positive and the negative voltage. So, we can transfer data by using the encoding. We can do line encoding which is necessary. We have seen 3 types: bipolar, unipolar, and we have seen there is these types we are saying as a polar encoding. Bipolar, unipolar or a polar encoding. These 3 types are coming in the line encoding. But what we are saying, we can transfer the data by using the line encoding, or we can do again another method, that is nothing but the block coding. So what is meant by the block coding? It can be exceptional. We can take or not. But line coding will be necessary. So about the block coding, we can say to ensure the accuracy of the received signal, we can use the block coding. We can take any example like even parity, 1 parity bit, we can add to make count of 1 in the frame even. It means what? We can use the block coding to ensure the accuracy of received data. So here block coding is represented by slash notation. It means what? We can give the slash and we can represent the block coding. By any MB, NB, we can represent how many bits. M bit block, if we are having N bit block, you can take slash NB or MB. M means we are using the M bit, N bit, and B for block. So we are saying this type as a block coding. So here we are supposed to study about the block diagram of communication system, in which when we will give the data to, this can be audio signal, we can give that data to the transmitter. Transmitter will transmit this data by using the transducer, amplifier, modulator via channel, and the channel we can use as cable, you can take optical fiber, free space, and it will transfer the data to the receiver, and receiver will give that data directly to the loudspeaker, to the computer, to the person by using the antenna, amplifier and the oscillator. So here, what we are saying, which type of information we are having and how we are transferring this data. So here, what we are saying, that data can be in any form. That data can be in audio signal, music, voice is nothing but the audio, data, email, etc. And what we are doing, we are communicating, we are transferring that data. So there are different types of the communication system, like public switch telephone network. We can take voice, we can take modem, fax. In this, by using these electronic devices, we can transfer the data. We can take radio, TV broadcasting, satellite system, cellular phone. We can use computer network also, like LAN, WAN. You can use this type of network to transfer the data to communicate with other person. So here, how we are representing the data? Communication system will convert the data into a electrical, electromagnetic or the optical signals that will be appropriate for the transmission of media. So here we can transfer analog data. It means what? It will convert analog data into a it will convert that analog data into a digital. It means what? Here we can transfer any type of data via channel. So here, if we are converting the digital data, we can say digital system will convert the digital data into a analog signal. So if you see analog signal converted to the bits by using the ADC, that is nothing but analog to digital conversion, or we can convert digital into analog by using the DAC, digital to analog converter. If we are having the data, at that time we can convert that data by using the computer, and most information can be converted into a bits. But why we are supposed to take the data digital? Because if you see, digital techniques need to distinguish between the discrete symbol and amplifications. So here, good processing techniques which are available for the digital signal, like data compression, we can say as a source coding. Error correction, we can say as ADC, analog to digital conversion. Equalization, where we will get the same value, only we are converting analog into a digital. Again, we can take medium that will be have security. So if you see, as compared to the analog signal, digital signal is easy to mix, and we can transfer that data by using the digital techniques. So here we can see, I have drawn the diagram, that is nothing but the pulse degradation and the regeneration. So what we can say here, by using the digital communication system, we are supposed to transfer the data. How we are transferring? If we are having the data that will be analog or a digital, we can convert that data into a digital. So here I have shown how we are doing conversion. So you guys can see here, firstly we are taking the original pulse signal, after that we can transfer that data, which will have some signal distortion. After that, again we can remove that distortion. So we will get the degraded signal at the distance 3. After that, what we can do, if that signal is badly degraded, we can again do amplification to regenerate the pulse. So here we can do regeneration, because we are using the digital communication, because these are most prevalent communication system in today's world of internet, mobile or any other means of the communications. This system, if you see, are popular because they are having lots of advantages. Like it is easy to regenerate a digital signal compared to the analog signal. Because if data is transmitted through a channel, it will get distorted because of non-ideal frequency response. But if unwanted electrical noise and the interference will affect the signal. But if you see, instead of analog, if you are using the digital, in case of digital signal, it is easy to regenerate the signal using the simple circuit. That is nothing but you can use the regenerative repeater. You can use the regenerative repeater like figure 1.1. I have shown how we are regenerating. Amplification to regenerate the pulse. We can use, so it is the advantages of the digital system over the analog system. Again, if you see, there are having lots of advantages, like it is having the noise immunity. If you see, digital circuit operate in finite number of states. That is nothing but it is operating only in two states, 0 and 1. Because they are using only two binary numbers. So the disturbance and the interference must be large enough to change the state. Thus the noise and other disturbances we can prevent in the digital circuit. But if you see in analog, there are infinite states, hence small disturbance can entirely change the shape of waveform. So we will get the distorted signal. So by using the digital signal, we can regenerate that amplification. Again, if you see, we can take advantage like flexibility. With the help of digital signal processor, it is possible to implement digital communication system. So this processor also we can program to make any change in the system. If you see, we can use digital system because as compared to the analog, it is having lower cost. Because of very large scale integration technology, the cost of implementing digital communication system will get reduced. Again, there is a concept of multiplexing we can take in the digital communication system. These are the advantages you are supposed to write. If there is a question, explain advantages of digital signal over the analog. Or sometimes there will be question, why we are using the digital signal instead of analog signal. So you can say these advantages. We can use digital signal because it is very easy to regenerate digital signal as compared to the analog. It is having higher noise immunity. Its cost is low as compared to the analog signal. It is very flexible. With the help of digital signal processor, it is possible to implement digital communication system, and this processor can be programmed to make any change in the system. Using time division multiplexing, we can combine digital signal so that we will get the different types of messages. That can be voice, data, audio. We can multiplex that data, and it is simple than combining the analog signal by using the FSK, frequency shift keying, or you can say frequency division multiplexing. If you see, instead of analog, if you are using the digital signal for transferring the data, at that time you will get different types of signal. That can be voice, audio, that can be multiplexed, and it is simple than combining the analog signal. So these are some advantages of the digital communication system over the analog. Again, you can take some advantages like it is suitable for most of the devices. If you see, for the security, digital information we can encrypt before the transmission. Hence, we will get the protection against the intruders. If you see, for the reliability, the digital circuit are more robust as compared to the analog circuit. The digital communication system are most compact due to the increased scale of the integration. Data compression is possible only in the digital communication system by using the source coding technique, which will reduces the bit rate. So these are some advantages. There are some disadvantages also, like there is a need of synchronization, because here we are transferring the data that is only in the digital form. So we will need the synchronization at various levels, and digital systems are required to allocate significant share of their resources to this task. there will be lot of attention will be needed for that synchronization while we are designing digital system as compared to the analog system. If you see, again there is a signal processing complexity, because when we are using the digital communication system, at that time intensive signal processing is required. So system will become complex. Non-graceful degradation. It means what? When the signal to noise ratio drops, the performance of digital communication will also drops drastically, and when signal to noise ratio drops below the specific level, at that time the performance of system will become very poor. So these are the some disadvantages of the digital communication system. It is complex as compared to the analog, because signal processing is complex here. It will require synchronization. So there is a need of synchronization. Non-graceful degradation. Again, if you see bandwidth requirement, because they require more bandwidth as compared to the analog signal. Now we can see the next point, that is nothing but the block diagram of typical digital communication system. So here you can see the block diagram in the figure 1.2. Block diagram of digital communication system, if you see, it will consist of formatting, source coding, encryption, decryption, and the channel encoding, multiplexing, demultiplexing. So we can see one by one. What we are saying here, when we are supposed to transfer the data, at that time, if we are transferring that data in the form of digital communication, so here we can take our information that will be input, and we can give that source to the format, and here formatting will be done. What does mean by formatting? When we are giving the information, that is nothing but the source. At that time it will be represented by source. It need to be converted into a binary format. So the formatting block will convert source message into a bit message. It means what? It is converting the data. It is converting the data into a bits, where we will get grouped to form a message. Example, by using digital communication system, we can do a formatting, like we can convert audio signal into a bits by using the PCM. PCM is nothing but pulse code modulation. It means what? Here we are converting analog signal into a digital signal. Again, after that, what we are using? We are using the source encoder. So what does mean by encoder? Encoder is a device that converts the active data signal into a coded message. It is a device which converts analog signal into a digital signal. So it is a combinational circuit that converts binary information in the form of 2n input lines into a n output lines, which represent the n bit code for the input. So when we are using the source coding, at that time it is applied to the message symbol to take advantages of redundancy in order to compress the message. This is one way of improving the transmission efficiency. So here we can use the source coding. At the output we can use the source decoding at the receiver to decompress this signal. After that we are using the encrypt. Encrypt is nothing but we are doing the encryption. So we can see the same time we can see at the input and at the output. Here we are using the encryption. At the output we are using the decryption. So in order to protect the transmitted signal from unauthorized user, we can do suitable encryption technique that can be used at the transmitter, so that only authorized user can decrypt that message at the receiver. So it means what? Here we can give security by using the encryption, and who will have that code? Only authorized user can decrypt that message at the receiver end. After that, what we are doing? We are doing the channel encode and channel decoding. So what does mean by decoding, encoding? There are the number of transmission impairments the transmitted signal can undergo when it is transmitted through the noisy channel. So the distorted signal gives rise to error in the detection and suitable error control technique at the transmission. So we can again do decoding at the receiver to improve the reliability of the transmission. What we are doing here? Again, when we are giving encoded input to the multiplexing, at that time we can do multiplexing. It means what? Digital communication system take the advantages of the time division multiplexing. TDM. It means what? It will take TDM because of discretization of the signal. We can take number of similar or the dissimilar matches can be combined and transmitted together. We can transmit number of data at the same time because we are taking that data combinedly, and we can transmit that data combinedly using the TDM at the transmitter end. What we are doing at the receiver? We are doing the demultiplexing. It means what? When we are doing the demultiplexing at the receiver end, that will allow this message to get distributed to the respective destination sink where we will be needed. At that point, we can transfer that data. And because of this, we will be needed the proper synchronization. If you see, after that what we are doing? We are doing the pulse modulation. So what does mean by pulse modulation? And at the receiver we are using the detection, DETECT, I have written here. So this is nothing but the detection. So the signal was in the binary format and it is ready to transmission. So if the channel is wired, the bits of the noise to be represented into electrical pulses. And here we can do the pulse modulation that will represent the data into a suitable line coding that can be unipolar, bipolar, non-return to zero, polar. It means what? Here we can convert that data into a suitable line coding, and this will depend on the transmission bandwidth and transmission power. But if you see at the receiver, we are using the detection. So the receiver pulse corrupted by noise are reshaped and detected by using the detector at the output side. Naturally, we will require filter to eliminate that noise. Again, if you see after that, we are using the band pass modulation. It means what? Here we can use modulations that can be TDM, time domain multiplexing, or you can use frequency division, multiple access. You can use code division, multiple access. It means what? A single channel can be shared by multiple users, and multiple access technique you can use any TDMA, CDMA, FDMA. So the spread spectrum and multiple access technique, if you see, we are using at the output to convert that data into a multiple users. We can give that data into a multiple users. Here we have seen the block diagram. Remaining syllabus we will see in the next session. Thank you.